Okay, so last time we looked at finding the limits of continuous functions, and we showed that we could evaluate them by direct substitution. And it turns out that, at least when given an algebraic type of equation of the usual functions, it tends to be that if you plug something in, you can find the limit directly. But the one exception where if you plug something in, you get a real number out, and you don't actually get the value of the limit, and it is defined, is going to be with piecewise functions. So a piecewise function is something like this. It's a function that's defined basically differently depending on what the domain of the function is. And we're especially going to be interested in finding the limits at these transition points. So notice that we transition at the points x equals 2 and x equals 4. So if I were to ask, well, how do I find the limit as x approaches 2? This is a case where I can't just plug in 2 and actually find f of 2. So finding f of 2 would just be a matter of plugging in 2 into the respective piece and dealing with it that way. So 4 minus 2 is 2. We can't actually do this. So what we do instead is that we can actually compute the left-hand limit and the right-hand limit by effectively evaluating the corresponding piece. So I think the easiest way is just to do it. I think it's a little bit hard to explain, but if I remember if the left-hand limit and the right-hand limit are the same, then the two-sided limit will be equal to that. So if I want to figure out the limit as x approaches 2 from the left, I want to look at what happens when I evaluate this function on the piece that's to the left of 2. So I can just substitute into the top piece here. So this is simply going to be plugging in 2 into the top piece. So that's going to be 2 squared minus 2, or 4 minus 2. We just did that over there. It's the same as the value of the function. But to find the limit of f of x as x approaches 2 from the right, we're going to do something a little bit different. We're going to plug in 2, but we're going to plug in 2 into this piece here. So all we have to do is plug in 4 times 2 minus 6. So that's going to be 8 minus 6. And this is also equal to 2. So even though they were two different pieces, we got the same value. And because these are the same, it turns out that the two-sided limit will be equal to 2. Now let's try to do the same thing for the second transition point, which is going to be x equals 4. So if we plug in 4 for x, and again, if I want to find the left-hand limit, I just plug it into the piece that has values to the left of 4, which will be the 4x minus 6. So that's going to be just 4. So notice here that we are we're basically doing like a modified substitution. But again, this is acceptable. So 16 minus 6, that's going to be 10. And then if I want to find the limit as x approaches 4 from the right of f of x, that's just going to be the bottom piece when we plug in 4. Now, of course, because this is a constant, when you plug in 4, nothing happens. It's just 8. So notice here that these are not the same. And thus, the two-sided limit in this case does not exist. So this is the general method of algebraically finding the limits of piecewise functions. What you need to do is that you need to basically plug in the left-hand piece, to figure out the left-hand and the right-hand limits by plugging it into the value that is defined to the left of 2 and also to the right of 2. and then do the same thing for 4 if you've got multiple pieces, and you have to check to make sure that they're the same. That's the key. And again, this can make a lot more logical sense if we consider the graph of this function. So if we were to graph this function, you'll see that we actually have our 3 pieces. So the top piece is the one in red, and then this will be the blue piece, and this will be the green piece, all in red, I know, but as you can see it too, even though there are 2 separate pieces, they both have the same limit value, whereas here, this will be a filled-in point, and then this will be a circle. So the limit will have there'll be a jump discontinuity at that point. So, as I said before, that is how we find the limits of piecewise functions. And as always, take care.